Probability is about making sense of randomness. We live in a world characterized by randomness, and we don't like it. As a species, we wish to control the world around us, but we can't. Fortunately for us, however, some clever little hominid developed the scientific method, and mathematics, and statistics, to give us a way to describe the randomness in the world around us so that, rather than controlling it, we can adapt to it. Because the whole universe is a big, inaccessible place, we have to start where we are. We have to learn about the world around us. We learn how things work on a small scale, and then we apply what we learn to larger and larger projects. In statistics, we call the big stuff the population, and the small stuff that we study, we call a sample. Our goal is to take what we learn from our sample and apply it to the population. If I want to know how many times does your heart beat in a minute, I could count your heartbeat for 60 seconds. But how else could I measure that? How does your nurse calculate your heart rate? I could measure for 10 seconds and then multiply by 6. Or I could measure for 6 seconds and multiply by 10, or 15 seconds and multiply by 4. But what if I want to know how many times does your heart beat in an hour? How could I measure that? Depending upon what I want to know, I could measure for a short time, then multiply, and that would work for a resting heart rate, which is a minimum. But what if I want to know how often your heart beats in a typical hour, including the times when you're active and when you're resting? I would do better to measure your heart rate for short intervals at multiple, randomly selected times throughout the hour, and then average those rates. By taking multiple samples, I get a better measure of the actual number of heartbeats. I take what I learn from the samples, and I apply that to the population. So the population is the entire collection of units that a researcher wants to study to learn something about the world. The entire collection of units could be people, or bees, lizards, fleas, sesame seeds, hibiscus trees, or clever little hominids, etc. Each of the individual elements in the population is called a unit. We may call those units subjects as well. A sample is a smaller, but hopefully representative subset of units drawn from the population of interest. Subjects are participants in the sample. APA style is to call people participants. So if you're studying people, your subjects are participants. But if you're studying hibiscus trees, then your participants are subjects. We want to determine truths about a population, but we only have access to a sample. We study the sample in hopes of generalizing what we learn back to the population. But of course, we can only generalize if our sample is representative of the population. That is, the sample should have the same characteristics as the population. But if the sample is not representative, then what we learn from the sample does not generalize back to the population. And this, in a nutshell, is what makes bad research bad. In poorly designed research, we learn only about the sample. Nothing that we learn from the sample applies to anyone else, so the research does not replicate. If someone else does the same study, they do not get the same results. Nothing is learned. No one has done science. And the research was a waste of time and money. And that is why it pays to learn to do research design as well as statistics, so that what we learn from the sample tells us something valuable about the population.